Hello, fourth graders. So I just recorded the video for Unit 5, Lesson 6, Part 1, but then my microphone, the wrong one, was selected, so there's no sound in the whole video, but I already wrote on my page. So what I'm going to do is I'm going to uncover things as we discuss them, and you can write them down as if I were writing it down with you. So in this video, we're introducing the ideas of perimeter and area. The prefix peri means around. The suffix meter means measure. So the word perimeter, I guess, is the measurement of the distance around the outside of a figure. So here we have a couple of different shapes, and over here on the key it says each one of these, like this distance is 1 centimeter. So what I did was I went around and I counted 1, 2, 3, 4. This is 4 lengths of 1 centimeter, so 4 centimeters. And I did that for all of my shapes. You can go ahead and do that too. Don't just copy mine, go ahead and count them, because that's the focus of the activity right now. Okay, hit pause and hit play when you're ready to move on. So, number 1 says the measurement unit for these rectangles is 1 centimeter. How can you find the total number of centimeters around the outside of each rectangle? What you can do there is you can either count like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and you've gone all the way around and you've done 14 centimeters. So you can count. You can also add, right? So if you labeled this side as 4, and this side is 3, and that side is 4, and that side is 3. You could go 4 plus 3, 7, plus 4 more, 11, plus 3 more, 14 centimeters. Another thing you can do is you can get 2 of the sides, add those together, and then double it, because this side is equal to that side, and this side is equal to that side. And that's something you can really only do for a rectangle or a square, or anything that has equal opposite sides. Okay? So, I wrote that we can count, add up all the sides, or add up the 2 adjacent sides, which are the 2 sides that are touching. So add this one or that one, but it wouldn't be just these 2 because then you're going to miss that one, and then double it. So go ahead and write that down. Okay. Then it says, what is the perimeter for rectangle X and Y and Z? So go ahead and find that distance all the way around. We're not dealing with the inside, just the distance around the outside. So for this one, it's 14. Here we have 2 and 6. So 2 plus 6 is 8. Double it, what do you get? 16. And then this one, rectangle Z, is 5 and 1. 5 plus 1 is 6, double it, and it's 12. Okay, so write these down. So X is 4 centimeters, Y is 16 centimeters, and Z is 12 centimeters. You'll notice it's just regular centimeters, not centimeters squared, because this is singular dimension, just 1. There is kind of an invisible 1 here, but there's like no point in writing it, so we usually just don't write it. Okay, then here, it says, how did you find the perimeter of each rectangle? Well, you could have done any of these things. I think my favorite is to add up the 2 adjacent sides and double it. Then it says, look at the key. Length is the distance across the rectangle, and width is the distance up and down. Perimeter is the total distance around the outside. Use the letters L, W, and P to write a formula for the perimeter of rectangles. And I put the cursive L because I think this L looks like a 1. So you could see it either way. It's easier when you're typing to make it look like an L and not like a 1. So use the cursive L if you'd like. So did you write a formula? Okay, here's what I wrote. So you could do L plus W plus L plus W equals P, right? That's the length and the width, and the length and the width. You could do the length and the width times 2 equals P, or you could have the length times 2, so the 6 times 2, which is 12, and then the 2 times 2, which is 4, and add those up, and that's the perimeter. And they all look like basically the same thing because they are basically the same thing. They are equal to each other because these are all different-ish ways to find the exact same thing, the measurement around the outside of the shape. Okay? All right. Now, let's go ahead and turn the page And on this side, we're talking about the area, okay? So the area is the total number of square units that cover a figure. And square units, a unit of measurement in length is like feet, inches, miles, meters, yards, any of those. But when it has that little 2, that means it's a square unit, okay? Because, you know, a square is 2 dimensions, and we're talking about a 2-dimensional figure, the area. Each square unit inside these rectangles is 1 centimeter long and 1 centimeter wide. So it is 1 square centimeter. You can see it written like this or with the little 2. It's the same thing. So I have my rectangles here. I labeled the distance on the sides, and then here's our key, length, width, area, the capital A. How can you find the total number of square centimeters inside each rectangle? One thing you could do is count. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But another thing you can do is you can multiply the rows and the columns, right? And see how many, you have 4 rows, you have 3 columns. That makes altogether 12, which is the same as what you get when you count them, because they're equal size groups. So you can count or you can multiply the length and the width. What is the area of X? Rectangle Y, rectangle Z. So go ahead, choose an approach. You can either count. I prefer that you multiply because it's like more practical, especially when you get into larger numbers. So go ahead and try to multiply the length and the width. And then using L to stand for length and W to stand for width and A to stand for area, what formula can you write for finding the area of any rectangle? So you can have area equals length times width or area equals width times length. Those are the same thing because of the commutative property of multiplication. And over here, I have this silly doodle because this question here says, why does the same formula work for all rectangles? All rectangles have 4 equal opposite sides, have equal opposite sides, so the opposite sides are equal to each other, and have 4 right angles. And I drew this silly little shape here because this formula doesn't work for all shapes. It just works for rectangles. It'll work for a square, it'll work for a rectangle, but it won't work for a shape I showed you earlier, like that, because like where's the length, where's the width? You know, you need a very fancy formula to find the area of a shape like that, or a different kind of formula to find an area for a shape like that. But this is for rectangles, okay? All right, my friends, thank you for joining me. I'm so sorry that my sound didn't work last time. Hopefully this still made sense, and I'll catch you next time. Bye-bye.